Good afternoon, I'm Norm, Textplus, and Textplus is a platform providing text messaging, domestic international calling. You can download it for your mobile phone, your iOS, Android. I think we're coming out with the Windows versions very soon. I'm going to discuss setting up a high availability environment for OpenSIPS.
Your Textplus?
Yes. Really going to discuss setting up the infrastructure, the architecture. We'll have some OpenSIPS snippets towards the end of the presentation. But what I'm going to do is try to provide a little theory behind setting up HA. People have slides that will go out that say, they'll have a picture of a proxy or a picture of a cluster of servers, and it's kind of nice. You've got the 3 or 4 or 5 servers all kind of stacked behind each other, and the pictures look nice. But honestly, I have yet to find a good presentation. There's a lot of information on the internet, but a good presentation that actually talks about how to set up the HA environment. OpenSIPS does work well in an HA environment, but setting up, But setting up the environment can be a little tricky, and there are lots of options. Again, as was discussed in a couple presentations before, there is no best way of doing it. You've got to look at your particular business case and what you're trying to accomplish. There are different ways of setting up an environment, an HA high availability environment. Again, I'm going to show just an example way of pulling it off. Your mileage may vary. SIP, as you may or may not know, SIP is able to be transmitted over UDP, TCP. You can have secure SSL connections. I guess the first part of setting up an HA environment, I'm going to discuss DNS, because to locate your servers, they could all be, they can be accessed via IP address, but more realistically, they're accessed via DNS. And DNS kind of falls short a little bit, or at least standard A record lookups fall short to try to transport or try to figure out how to route your telephone number if it's 555-1212 at example.com. Trying to route that somewhere and have it terminated to a server that's running UDP or TCP or TLS. You don't really know that when you're just given the URI. So we've got a DNS problem that we have to fix first. The first place we're going to go to fix this DNS problem is the name authority pointers. They're pointers that are used to map servers to user addresses. I'm going to show examples of these in a minute. Are used to map servers to user addresses. I'm going to show examples of these in a minute, because it can be a little confusing if you don't know DNS or DNS name pointers. The nice thing with the name authority pointer is that it will show you what services are available for your particular domain, your example.com domain. Are you terminating to SIP over UDP? It's going to go to one set of servers, SIP over TCP somewhere else. Basically, the results of your name pointer can be used as a lookup for SRV records. Again, what we're trying to do is get to a server and a port that's going to be able to service your particular request, given that we don't have a lot of information, just a telephone number at a domain. The SRV records, the service records, are basically used to define that host name and port for your services. For example, you're trying to get to information in Manhattan, 212-555-1212. We don't know the IP address to head to. We don't know the port. We don't know the protocol. Pretty much don't know anything, but we really do need that information in order to route the call correctly. At least to get to the right kind of set of servers. Again, this is like a very high level of how we're going to get to an HA environment. We'll drill down and get other, we'll get detailed, more detailed as we go. So the name authority pointer that we're using for example.com, in this case returned 3 addresses for us. The information shows, if you know DNS a little bit, you've got precedents, and you've got ways to arrange results that all have the same precedence or order. In this example, we've got, again, three results. The S in the middle shows that what we're doing is going to take this result and use an SRV lookup against it. Again, this is just an example contrived for the presentation. Name pointers have a lot of other functions and have a lot more capabilities. Most of the examples you'll see do have many more options, many more features. I've kind of trimmed it down as best I could for this presentation. So basically, the example.com domain is going to return, for example, sip_sip.udp.example.com, since primarily we're going to be transporting our SIP packets over UDP. The top line there shows that we're going to do an SRV lookup for _sip.udp.example.com, and our SRV lookup returned 2 different addresses for us. We still don't know where to route the packet to, just we know that we now have a choice of 2 servers, one with a priority of 10, the other with a priority of 20. We do know that we now are going to hit port 5060. Again, it doesn't have to be 5060 if the SRV results pull up something different. And we've got 2 different OpenSIPS servers that are being pulled up. 01 is in New York and 11 is in Los Angeles. So, for example, you can have a little bit of availability or load balancing to different locations. They don't have to all be on the same LAN or on the same network or on the same data center.
So it's here that if you have users on the East Coast, you go to 20, but users on the West Coast might go to 20.
Absolutely. There's lots of ways to play. You can DNS, and there's extensions to DNS that provide GeoIP lookups. As I said, things can get very complicated. You can do a lot of very cool things. I'm just trying to show a contrived example without getting too crazy, but you're absolutely right. This is just an example showing you could have different servers in different locations. As was pointed out, there can be GeoIP lookups so that the order is reversed if you're on the West Coast as opposed to the East Coast. If your IP address comes from the West Coast as opposed to the East Coast. That's assuming that all the IP addresses are legitimately set up in the GeoIP database. So now we know that we've got OpenSIPS01.example.com, and we do a host lookup. And by the way, these commands are all manual commands. Obviously, you wouldn't be doing this manually. This would be done behind the scenes via a device that supports the name authority lookups. It knows how to go down and get the actual information we're trying to get to. So our OSIPS01 example has an IP address of 192.168.1.213. We now have all the info that we need to route that call. We know that the Manhattan information number is going to this IP address at 5060 using UDP. So the DNS portion of trying to locate where to send that packet in a kind of a high availability or a, say failover at this point environment can require some DNS lookups. There's some overhead with DNS, but the value is that we now know where we're sending the packet, the message. Note, in a high availability environment, this 213 number, and I'm going to use the 213 host throughout the presentation. as not pointing to a single machine, but pointing to a virtual IP, an IP alias, a virtual IP that can float among multiple machines on your LAN. And that's the key. That's another kind of component that gets glossed over when somebody shows 3 or 4 machines stacked behind each other. It's like, wow, how do they all like work in a high availability environment, you know, load balanced or whatever. This IP address that got pulled up by DNS is not, as again, I'm just reiterating, does not point to a single server permanently. That IP address will float to different servers, and I'll show that in a moment. So now we've got, you know, a server. We have an IP address that we're going to. We're going to set up or just talk about the high availability servers. You obviously would need more than a single box. Actually, if it's a, you know, if it's a virtual machine, I guess you could have multiple machines on a piece of physical hardware. But ideally, you would want a couple of physical servers. If you're testing, you could certainly load up VMware or one of the other virtual kind of emulators and load a couple of images on there. Generally, each server is configured with an administrative IP address. I don't want to say generally, but by and large, you should have an administrative IP address that's not accessible to end users. That IP address generally does not float, and that does point to the physical instance that you're working with. Then there's a floating IP address that is used by end users. That's the IP address that was just returned to us by the result of the DNS lookups. Usually, the configuration, activation, and deactivation of that floating IP address on any particular server is done automatically. You can do it manually, but that doesn't really buy you much. A very key point is that IP address is only going to be active on one server at a time. Generally, you call that particular server the master or the primary. You don't want that IP address active on 2 servers at once. Well, I guess you could, depending on your business case, your business need. You may want that IP address active on more than one server. Again, this is just an example to show how it can be done. Not saying this is how you should necessarily do things, but these are examples that do work. So how do we move this? How do we deal with this floating IP address, this virtual IP? We set it up, or it's set up using a technique called IP aliasing. The manual commands to start or stop this virtual IP are shown. Generally, we can set something up on Ethernet 0:0. That would bring up the interface. Obviously, the down command would bring it down. It doesn't have to be Ethernet 0. It could be Ethernet 1, Ethernet 2, depending on how many physical Ethernet cards you have in your server, on your server. It doesn't have to be :0. If you've got other aliased IP addresses, it could be :1, 2, 3. But this is again just an example showing a very simple setup. If you display the Ethernet interface after you run the command to bring up your virtual IP, you'll see it's listed at the bottom. The 213 is listed at the bottom. Pretty standard stuff. If you guys, I'm sure everybody here is technical. It's all pretty standard stuff. You may or may not have ever set up secondary IP addresses on your interfaces. If you have, this is easy. If you haven't, that's how it's done. As an example, if you're a Debian, you can permanently create an IP address using the following kind of commands. Again, a virtual IP address, or this floating IP, or VIP, virtual IP, I call it VIP for short. You're not going to want to necessarily set it up with a static command. You're going to want to let some other tool, some other piece of software manage that for you. If you're on CentOS, there's a slightly different way of doing things to set up a virtual IP. Again, or set up an IP alias. Again, this isn't the only way of doing it. This is just an example. The idea is that CentOS and Debian have native support for setting up IP aliases. Again, an IP alias is just another IP address associated with your physical interface. So now we've got this floating IP thing. We've got the idea of setting up an IP alias on your server, and you think that you're great. You've got your HA environment. You're good to go. Well, it's not quite that simple because there are a couple of gotchas out there. Okay, when the primary goes down, you want the IP alias, the virtual IP, to move over to the standby, the backup, the standby, the slave, whatever you want to call it. And so the IP address moves over to the other server. Basically, what's done is the down. Basically, the manual commands that I showed you previously. The down command is done on the master. If the master is actually physically around, if the master is dead, there's obviously no need for a down command. And the up command is issued on the backup, the hot standby, the slave. When the up command is issued, great, the slave can now accept traffic to that virtual IP. The problem is that any other device on the LAN may very well have the virtual IP address cached in its ARP cache. Now you can't just tell the whole world to shut down its ARP cache just because you went to a backup mode. So you've got to take care of the gotcha, the ARP gotcha. ARP for people, again, this is getting into networking a little bit deeper, but it's very important in a high availability environment. ARP, what is it? How does it work? Typically, if you need to get to a server, the host, the server that is looking to go get to the other location, broadcasts the IP address on the LAN, and any other machines on the LAN that are responsible for that IP address respond with the MAC address. This is layer 2 kind of stuff. So the MAC address is returned associated with that IP address. The originating host stores that in its ARP table, so it knows where to send the packet physically on the LAN. The entries in the ARP cache typically expire after about 2 minutes or so. Again, it's configurable. And so that's how, and then the next packet that comes in for the VIP, the host out there knows the physical address to reach the VIP. The problem arises that the master might be inaccessible, but it might still be able to respond to ARP requests. If it's, let's say OpenSIPS is, don't listen to the blog, let's say OpenSIPS crashes, and, but the master is still there. Well, you really want to move over to the backup. So the virtual IP moves over to the backup, but the host may be in such a state that it's still responding to ARP requests. Now the server, the router, let's say, an incoming SIP packet comes in, the router says, where do I route this to? Well, guess what? The master and the slave are both responding with saying, yep, I'm responsible for the packet, send it to me. Well, that doesn't work because you really want the packet to go to the slave in this instance if the master's broken. Even if the master doesn't respond to an ARP request, traffic from any other servers or any other routers will still be sent to that master because nobody's told the master that anybody has failed over to the backup server with a backup MAC address. At least until the router's on. I'm just saying router because generally traffic comes in via router. Until the router's ARP cache is cleared. That's not good because that means your backup isn't going to work until, possibly 2 minutes, possibly longer. This problem, which is the gotcha for this high availability environment, is a technique or a thing or an idea called gratuitous ARP. Gratuitous ARP is an ARP reply when there's been no request for it. The server sending the gratuitous ARP, ideally the backup server, the hot standby, it gets the virtual IP. It's going to send out a gratuitous ARP. If it sends it to the broadcast address, again we're talking layer 2 here. If it sends it to the broadcast address, that means all the servers on the LAN are going to get an ARP reply that ties an IP address, the VIP, to MAC address, which is the standby server. This is going to cause all the hosts on the LAN to refresh their ARP cache with the IP address, the MAC IP address combination of standby, which is what we want. If these gratuitous ARPs are sent quickly enough or sent often enough, ideally, for this particular entry, the MAC address and IP address, they should never expire from any hosts on the LAN. So if they never expire, if all the hosts on the LAN get the IP MAC combination, which they should with gratuitous ARP, and they don't expire, that means that none of the hosts will ever send an ARP request out for this IP. If no ARP requests go out, then there's no chance that the failed master would ever respond, because there's no ARP requests coming out that the master has to respond to. This is, again, it's layer 2. This is how you would set up, or some of the things to consider as you're setting up multiple servers that need to, play nicely in a master hot standby kind of environment. Again, a lot of this is glossed over or not even discussed in other kinds of presentations, and you'd have to kind of glean some of this information off of different pages, wiki pages, or people's blogs on the internet. But this is one way of addressing the primary backup problem. Now, the downside, I won't say downside, but consideration is the gratuitous ARP. If you're saying that, yeah, I'm in control, or I have an IP address and it's associated with a MAC, it can be used maliciously. Obviously, if you're doing this on your internal network, you ideally hope that there won't be any malicious use. But because of the potential malicious use, Linux has gratuitous ARP disabled by default. And below are listed basically the syscontrol commands, excuse me, to enable some example syscontrol commands to either enable gratuitous ARP or disable it. Again, it's generally not turned on by default. So if you think, okay, here I'm going to load up a couple of machines, call one primary, call one backup, set everything up, and it doesn't work, well, it may be, one of the reasons might be that your devices are not accepting gratuitous ARP replies. Remember, gratuitous ARP is a reply without there ever being a request sent. There are a couple of, again, note the ARP traffic that we're talking about is layer 2 traffic, so it's all local on the LAN. It does not generally pass through switches or routers. So I guess we could pass through a layer 2 switch. It's not a network kind of protocol. It's a LAN protocol. So we're managing servers on a single LAN. ARP ping is a manual tool that you can use to, I believe, send requests or replies. ARP watch is another tool out there that gives you some visibility into what's going on at an ARP level. If you're going to set up an HA environment like this, I would suggest using the manual commands, get a good feel for what's going on, cause your primary backups to fail over and to recover, and see that things are working properly before you start.
So with this ARP thing, what if you end up with a scenario that both servers are, they think they're active right now?
Well, if they're both sending gratuitous ARPs out, then you have a problem. Then that's a race condition, and whoever the last one that sent that request out, that reply out, is going to populate everybody's ARP tables. So you want to make sure that you don't have two machines thinking that they're active at the same time, which is what we'll get to in the next slide. Moving the virtual IP address around and how to do it. You obviously don't want to do it manually. There are various programs to help you move these IP, manage these virtual IPs, these VIPs. ChorusSync is kind of a cluster manager, and it's put here because it's part of one of the tools that's pretty popular. It's used in this environment. Heartbeat, I believe, is a project that's been depreciated, deprecated. Not sure how you want to pronounce that, but I believe while Heartbeat is still out there, and you can actually pull it down. I mean, it's still in the repositories. I think people are saying that Pacemaker is the replacement for Heartbeat. And again, most folks here, you guys are technical, so you kind of know what I'm talking about. Keepalived is another tool to help manage the movement of IP addresses, the virtual IP address, the VIP. And VRRPd is another tool. I tried to order them in complexity in terms of configuration and weight. They have lots of features. The first few, you're going to see some config file examples that show, yeah, there's a lot of complexity in setting this up. As you get down, VRRPd is pretty slick because it's configured via command line, one line, that's it. Configure the whole thing. So depending on what you're looking for and how heavy you want this process to be, it can be very lightweight or it can be pretty heavyweight. ChorusSync, again, it manages clusters of servers, typically used for Pacemaker. One of the things, it does require a couple of config files. I highlighted the bind address. It is the administrative address, not the VIP. ChorusSync is going to use that, I believe, to try to kind of pass packets back and forth to let you know that one server is alive, the other server is dead, so that you don't have the case where you've got two servers thinking that they're the primary at the same time.
I'm trying to multicast address. Do you need a multicast package between two servers and then to avoid the verification?
That's just an example. Your mileage may vary in how you set up the settings. I basically just showed the. I'm sorry.
First, is not required.
Right. No, again, this is just an example. I'm not saying the idea was to highlight a line. You're going to be pointing. On one machine, this is pointing to the other's
Right. You're going to try for the
administrative address. The other machine is going to point to this server's administrative address. Pacemaker. Again, there are a couple of different ways to set up Pacemaker. This was, again, I pulled some of these off of blogs and off of items on the internet. So, at the end of the presentation, there'll be a list of references that you can go back and see what's going on. But basically, to set up a Pacemaker cluster, you've got to run some commands. Again, it's a little bit complicated on CentOS. You'll find that some of the commands, like CRM, have been taken away and replaced by the Pacemaker configuration system, PCS. So some of these configs may or may not, some of these examples may or may not work in your environment. But the idea is that you are setting up the VIP down here. You have to configure some nodes, and then you set up your VIP on an Ethernet port, on an Ethernet interface. Just showing that it's relatively complex to set up. In Pacemaker, you're still adding some more information. You've now got to set up your locations. And again, if you're going to monitor, you specify some time intervals that you want to monitor. Again, it's a little bit heavier weight. It's got 100 features beyond what I'm showing you here. The idea is it's a heavyweight tool to manage services, manage moving VIPs around. These tools will also manage bringing up and bringing down services, but that's not really what we're talking about. We're talking about just moving the VIP from one machine to another. Heartbeat, again, the predecessor of Pacemaker, is a little bit easier to configure. It does require some auth files, and it does broadcast heartbeats thus the name Heartbeat. And I guess Pacemaker being the the add-on when your heart's not doing well, you get a pacemaker. So again, you've got some config. It's a little bit less, of some setup to make this happen, but there's still a little bit of setup. Keepalived is another tool that does the same sort of thing. It's much lighter weight. It's written in C. It's got, I believe, just a single config file. There might be other config files if you want to do some other things. But a pretty simple example shows is shown again with the virtual IP address specified, put in bold. Again, Keepalived is a little bit lighter weight than Heartbeat or Pacemaker. And again, as I said, VRRPd is the winner in terms of lightweight, virtual router redundancy protocol daemon. Boom, a single line. The primary is defined, the backup is defined. As I said, the .213 is our bit throughout the presentation. It's on Ethernet 0. We've got P as priority. The nice thing, go to the website, there is the VRRPd. There's also somebody, and I don't recall his name, and I should probably give him some props, that came out with an advanced version of this. So he adds a couple of extra features. But again, a very lightweight tool to move an IP address.
Services, and can it bring and move services from one machine to the other?
I'm sorry?
Can it move services from one?
Well, because it's lightweight, it doesn't by itself do that, but I believe that you can run file supplementary options. So you could create a script that says, bring something up, run if you're in FreeSWITCH, run a recovery. So yes, while it doesn't do it itself because it's lightweight, it'll run your script. Some of those other tools, you configure the services that you'd like to have brought up or brought down.
And then you're lucky to configure it right in order to work.
Correct. Some of the other tools, when you're moving services around, what happens when the master comes back up? You've now rebooted the master, you've replaced the hardware, or whatever you've done. The master comes back up. Do your services stay on your failed server, or do you do another movement of the bit and everything goes back to your master? So there are a couple of ways. There are lots of ways to get to the result that your business case requires. I'm not suggesting any one way is better or worse than the other. It's really dependent upon your business case. No one tool is right for everyone. You know, if all you have is a hammer, is that what it?
Everything looks like a nail.
There you go. Then everything looks like a nail. So you've got different tools to automate the movement. But this is all the backwork of the system admins, and I'm assuming everybody here is technical system admin of some sort. These are the kinds of tools to set up your HA environment. As I said, we're not quite talking about OpenSIPS yet, but you can't really do anything in an HA environment without having, the groundwork laid. And then what I'm trying to show here is laying the groundwork. Now that we've laid the groundwork and you want to run an application like OpenSIPS or FreeSWITCH in an HA environment where you've got a, yes? I'm sorry?
Can you verify that the VRRPd, that the reason that it's so lightweight is that it uses a Linux kernel? I think it's only Linux. Is it portable or is it only on Linux?
I don't know, since I only run, I do not run Windows machines. There are Solaris machines. I'm not sure if it would run on Sun or...
You have other protocols that you can use on Windows. This is a
Someone
protocol
else
normally used for routers, to make failover between routers, network routers. So in Windows you have another tool that you can, I don't remember the name, but you can check this on the internet because you have another tool to do this native on the Windows.
The CARP maybe, is that what you're talking about?
Yeah, something like that, yeah. It's the same thing. You have a VRRP protocol on Cisco too. It's there. All the same.
Now, and again, I'm gonna post this. I'll give this talk, and we'll post this on the web or whatever with the at the end of the summit, so everybody will have this. Now that you figured out what at the beginning, we figured out our IP address through the DNS magic. We now know what server we're headed to. Now we just got done configuring our VIP, our virtual IP, so that it's on a master or it's on a backup. So now we've got the machine, and hopefully it's going to stay up in a high availability environment. But now you've got to run some services on that machine. Services would be OpenSIPS. Well, the rub comes when you want to run OpenSIPS or have it run on your backup at the same time that it's running on the primary. You can do as you suggested, bring it up or bring it down. You become your backup becomes a master. You then run a script to start OpenSIPS. Now OpenSIPS starts very, very quickly, so that may be good. In other instances, you may not want that little bit of a delay. You may want to have OpenSIPS running as a hot standby on your backup machine. So you just move the IP and you're off to the races. Well, you can't bind, by default, you can't bind services to an IP address that doesn't exist on your machine. When the VIP is over the other place, you no longer have it on your machine here, and you can't start a service that needs that IP address. This has obviously been a problem, and it's been fixed via another syscontrol command called non-local bind. Again, non-local bind can also be used for bad purposes, and so it is disabled by default on Linux.
So why would you need it on FreeSWITch as well? So this setting is required by both OpenSIPS and FreeSWITch.
If you were running a FreeSWITch server in the same environment, now we're not running these. Everything has been generic until now. The DNS has been generic. The setting up of the VIP has been generic. Now we want to run a service. Well, let's say we want to run FreeSWITch. FreeSWITch is not going to be able to bind to an IP address that does not belong to that server.
Or if you're running on the same server, the FreeSWITch is on the same server, you need it. Like let's say if you're running
You have a master. Right. Oh, if you run OpenSIPS and FreeSWITch on the same machine, you still need this.
No, but if your FreeSWITch is not on the same machine, then you won't need this, right? Or if the FreeSWITch.
If FreeSWITch is in a high availability environment, as we're discussing here, where it binds to the VIP, and if that VIP is not on that server, let's say there's two FreeSWITch machines, and you've got this VIP going back and forth between the two. If the VIP is over here, the FreeSWITch over here is not going to be able to run without this setting.
Why would you want to have that VIP for FreeSWITch?
Why would you want to have FreeSWITch in a high availability?
No, but if you have OpenSIPS, right, it's going to detect which one is available or not. It's just going to send it to that, right?
Because it is universal.
Oh, okay.
He isn't saying which ones.
I'm using that as an example. OpenSIPS has other mechanisms to determine if let's say a FreeSWITch box is available or not. Yeah, so OpenSIPS has some tools, and we'll look at that a little bit. But this is, let's say we don't want to run OpenSIPS. We're not even running OpenSIPS. Sorry about it. Again, it's the second time. And we're only running 2 FreeSWITch servers for whatever our business case is. You would need it. You would need this setting in order for FreeSWITch to bind, or for any application for that matter, to bind to the VIP as it's on the backup side. Now, a couple of OpenSIPS configs to help. If you're using this kind of an environment, you definitely want the listen command for your VIP to be in front of the listen command of your administrative IP address. We've tried it the other way, and it's easier. Life works really well this way. SIP registrations in an environment where you've got a primary and a backup, a hot standby. You want to replicate your registrations so that, again, this is the old way. I guess now we just learned with the new release, there's the new way of replicating, hopefully to replicate registrations. But the old way is that you're going to have a master and you're going to have a backup, and you want to be careful. You want to save your registrations on your master and then replicate them over to the backup using commands. Again, I didn't know about the new features, so this is the old way of doing things.
No, actually, in 1.10, you have this replication only for the dialogues. For the register, it's not that. It's not still there. So it will be only in the 1.11.
In .11.
Yeah. So even in 1.10, you still have to, for the registration, you still have to do this.
Okay.
That's one of the reasons why 1.10 was not chosen as a long-term supported release. Because it's not, let's say, really consistent from the features point of view. We still want to add some more stuff.
Actually, and now that you mentioned the 110, the .10 and the .11, you labeled .10 beta. How long do you expect it to remain in beta?
Typically, based on the past experience, it's like around 1 month before getting to real stable. If nothing, let's say, critical comes up, like finding some, very spooky bug or whatever.
Right. An example config snippet for registrations. And again, this is going to be on the web, so you don't need to write it down or whatever. You want to save your socket information, and basically, I guess I'm not going to go through every line here. They say that obviously we're trapping just register requests, and then we save the location locally. If we're the backup, we save the registration locally, and we do specify a couple of parameters here. The M says that we're going to only write this to memory. Again, to be very fast. We're not going to use an external database. We're going to use the S command to save the socket information specified, hopefully in the header that came across from our primary. And we're going to set some expiration times because there's an open ticket on registrations. The expiration times when you specify them in the mod parameter. I think that's a 1.9 ticket. If you're the primary, again, this is the code. This is just didn't all fit on one page, so I just went to the next page. If we're a primary, we're going to save the information, the registration information. And actually, I'm one for like lots of log messages. Maybe I guess some of the new features. You said the script.
Script tracing.
The script tracing may reduce the need to have xlogs strewn throughout your code. I have like xlogs like on every other line just about, so I can trace my script. So I'm very interested in the script tracing. And then what we're going to do is we're going to replicate the registration off to the backup. So if we're the primary, we save it and we send the registration off to the backup. And this is a typical way of doing it. Most of the examples that I've seen never specify an on failure or on reply. I found that it's kind of useful, especially as you're building up the environment, to have your on reply and your failures logged, so that you know if your replication actually worked or not. Again, you've got a couple of machines, you want to know if there are any failures. There might be a network failure, there might be a failure on your backup. So logging this information is kind of neat, and it's pretty simple to set it up, although one of the things that I've noticed is pretty much every example that I've seen in blogs or in wikis does not show.
Is this working across multiple networks?
Across multiple networks.
Is this only for HA, local HA, or basically location?
Let's see, we can go back to the T-replicate. That's going to an IP address. So, and actually that's not the VIP, that's the administrative IP address. So it could go across networks. You could actually, if this is in Los Angeles, you could replicate it to New York. Then there are a couple of other programs that have already been discussed, so I'm not going to go into too much detail. Other presentations already discussed some of the different kinds of load balancing and high availability kinds of tools that OpenSIPS, the modules that are provided. The other, yes, go ahead.
To go back to the registration replication, is there a reason why this would be better than using, say, a master-master database arrangement to track the?
Well, you could store all this information into a database. Again, maybe you're going to be a little slower because you're not in memory. See, the M setting somewhere. Ooh, there's no M setting there, but there should have been.
For the primary.
Oh, for the primary.
You have it in the state.
There we go. We have it in the save location on backup. Again, not using a database means you're going to be fast. And if you want to be fast, you don't want to use a database in any way, shape, or form. I mean, there could be efficient databases, but it's still you're doing it right, and you're going to do a lookup out of the database when you do the a lookup location, a location table lookup. That's if you have a database, let's just say you've got a database out there. Now you've got to address high availability and failover for your database, because you can have one database that both OpenSIPs talk to. Now you've got a potential failure point there, and you may want to have some database replication, and that's another topic. It makes things a little more complex. And again, it's a little bit of a penalty performance-wise. When you're writing to memory, the penalty is you're going to run out of memory. If you've got 10 zillion registrations, writing them all in memory may not be an option, so you might have to go to a database. So then, yes, you could use a master-master database. You wouldn't need this kind of logic. And then you would have to make sure that you've managed your redundancy at the database level up there. We've got the load balancer. I'm not going to go over these too much. I just showed a couple of examples of the load balance of different tool modules that have already been discussed previously. I think somebody mentioned, he's not here, but yes, the load balancer can probe destinations to determine if they're up or if they're down. Obviously, it's not going to send. You can set it to not send any traffic to a down destination. So when he was asking about, well, why do you need to worry about load failover for FreeSWITCH? Just have it not go to that FreeSWITCH. Yeah, the load balancer can address that. An example of setting up the load balancer, you'd set your servers up as groups. You'd set up some destinations and resources. Again, you can pull these off the wiki. There's better explanations on the wiki, and you can take your time and review them. Some code that uses the load balancer is here as well. One of the interesting things is if we have a timeout, we can disable a particular destination. And again, if you look long and hard enough, you'll find, or in the references at the end of the presentation, you'll find some other examples of using the load balancer. OpenSIPS also has the dispatcher module, which provides a little bit different function, but also routes calls out to various locations. The dispatcher function also can probe a destination to see if it's up or down, and if it's down, not send any calls to it. So you can have OpenSIPS send calls to various places. One of the nice things that the dispatcher can do is it uses one of a few different algorithms to determine what destination to select. The nice thing is you can always force it. If there's a set algorithm, and if you need to know, let's say you've got 10 free switches, and you send a message off to free switch number 7, and for whatever reason you need to come back and determine, send another request off to that free switch or cancel a call to that free switch. If you use the same algorithm based on something like a call ID, you'll always hash to the same server, the same free switch. So you're always going to be able to hit free switch number 7. So that's one of the really cool benefits of. There may be other ways to skin a cat, but that's one of the nice ways that you can use the dispatcher. Again, the examples for using the dispatcher are very similar to the load balancer. Again, not a lot of code. A lot of the work has been done by Bob and his crew. You just run a couple commands, and you're off to the races. Dynamic routing was discussed as well, another module, probably the most complex of the modules. Dynamic routing can do all kinds of crazy things. Very simple, in a very simple form, you can have a carrier table and a gateway table, and again, you can route to, let's say you want to route to level 3 via a couple of different IP addresses. The dynamic routing module can do that for you. Again, the dynamic routing module can do a ton of other things, and I'm not going to talk about those right now because I just want to focus on the fact that here's a way to route out to different locations in a load balanced or in a high availability kind of environment. Here's a quick example of using dynamic routing, and as I said at the end of the presentation, I've got a list of references for this. I take a picture of that. But again, we're going to post this, so I think that the reference list is good because, again, depending on your business case, what you're trying to accomplish, there's a lot of good information. If you want to learn more about ARPy or Pacemaker, there's some links there. If you want to get more into load balancing, there's some, as Bob pointed out, there's some tutorials online. Those are places where you can sit down in the privacy of your own desk and rock and roll. Again, the references, as you guys all know, get them while they're hot. Sometimes they go out of scope. That's it.
Question: why do you need
A name authority pointer?
And with the SRVs, isn't SRV enough?
Well, if you're what the name pointer does is it will hold different records based on a UDP, for example, TC.
Should have an official SRV record, to be honest.
And yes, you will need SRV in these examples. Yes, you would need SRV records behind it, and usually you would have multiple SRV records because you're going to want to return multiple servers in some sort of a priority. And then those SRV records point to the A records, and that gives you your IP address.
Is it standard? Is SRV 2.0 is not, I would say, is not something that is really reliable. I'm not going to say it's not reliable, sorry, but I've seen a lot of inconsistencies, especially when you go with the master-slave kind of concept, that it's not really giving back the right record. Is there any way how we could get it around?
Well, the way is to own the domain.
We own it.
It's your TTL, basically. You have no.
It's really not the giving out the right record part. It's the client just chooses once you get the data back what to do.
Well, SRV records do come back with a priority, and you should. The client should choose the lowest number. It's exactly if the client just chooses to return the very first entry he gets back. That's a bug in the client.
Routers are causing problems, and I have not ruled out any consistencies where I couldn't find anything that this is the problem. I couldn't basically pinpoint the problem, but we're constantly running into this kind of issue that an SRV records are going to a failover server before going to the primary.
That's actually.
There are bad times. Well, I can almost guarantee that SRV records are not always returned in the same order. Priority aside, they are not always returned in priority order. And clients that don't look and don't listen to the priority will not choose the correct.
So it's basically a blind point.
Yes.
There's also routers that do not route the SRV records. They don't support SRV records. You have some DNS proxies on this very basic routers that simply do not understand anything about SRV records.
I've seen a lot of interesting ideas.
Thank you, everyone.